All right, last video. Let's go for Unit 12. So we're on problem number 20, but before that, we're going to show you the vectron. Have you seen my vectron? Here's my vectron. Whoa, look at the vectron. So it's an anti-gravity device. You see it spinning around? Yeah, spinning around. Huh. Whoa, anti-gravity. Anti-gravity. Whoa. Whoa, that's crazy, right? Anti-gravity. Whoa. Woo. Whoa, look at that. That was pretty cool. That was pretty cool. Woo. Pretty cool. Okay, here we go. We're almost there. So our last one is set up for substitution. How do you know it's set up for substitution? Because it's set up for substitution because it's already solved for letter. It's already solved for letter, right? It's already solved for y. Already solved for y. Nice. So if this equals y, which it does, that means that if you see another equation with y, you can just plug it right in. Way-o. So we get 2x squared plus 3x minus 1 on one side of the equal sign equals. Then on the other side it'll be 2x squared minus 2x plus 9. Way-o. So now we need to get everything on the same side and factor it, or set equal, solve for x. Because look what happens when you minus 2x squared to the other side. 2x squared minus 2x squared cancels. Way-o. So now you're left with 3x minus 1 equals, those canceled, equals negative 2x plus 9. So we'll get all our x's on the same side, right? Get all our x's on the same side. So that's 5x, because we added 2x to the other side, minus 1 equals 9. Then we'll add 1 to the other side and we get 10. Whoa, that's convenient. And now we divide by 5, divide by 5. And so when you do that, you get x equals 2. Woo! So now you just need the y value. So you can choose the top or bottom equation. And wherever you see an x, you're now going to plug it in and solve for y. Solve for y. So let's say that x equals 2. So wherever you see an x, you're going to replace it with a 2. Replace it with a 2. So 2 squared is 4. Don't forget the times 2. And 2 times 4 is 8. And then 3 times 2 is 6 minus 1. That's 14 minus 1 is 13. So y equals 13. And so now we have our coordinate 2, 13. Way-o, found an intersection. We found our intersection. Now I'm just curious, so I'm just wondering there, did they like both land right on the vertex? Because usually 2 parabolas will cross each other, and you should have 2 solutions. So let's just investigate for 2 seconds and see what we got there. So here's one parabola, and then the other one is also 2x squared minus 2x, and plus 9, right? So let's graph and see what happened there. So I don't see an intersection. We might have to extend our window. Maybe go really high, like 20 or 30. Boom. Ooh, so I see the one intersection there. Right about there, right? Second, calc. And then we go intersection. We go enter, enter, enter. And guess, yep, right there. So there's our 2, 13. But won't they ever intersect way up there, sky high, high? Let's just see what happens. What if we put in like 100? Still not intersecting. What if we put 1,000? Whoa. So we see the one intersection there, but yeah, they don't seem to intersect. I guess other than that, I guess one's wider than the other. Let's change our minimum and maximum to -50. I just wondered if there's another intersection there or something maybe. Ooh, yep, just the one intersection. That's crazy. That's crazy. What about 10,000? Woo! Right? Still don't see the other intersection. Okay, I guess we're good then. Just the one intersection. Good job. Okay, beautiful. So then you're going to do some word application problems. So a rectangular pool has a perimeter all the way around of 126 feet. Pause me. You should try this one on your own. Come on. You got to face the test. You won't have videos then. Pause me. Try it on your own. So the length of the pool is 3 times, let's see, the length of the pool is 3 more than, so +3, then twice the width, 2 times the width. So length equals 3 more than 2 times the width. And so there's our formula with length and width. Find the dimensions of the area of the pool without using your calculator. Label your answers. Okay. Well, we do know another formula that we could use to substitute into, and that's the perimeter. So the perimeter is length and width and width. So length plus width plus width. So that's 2 length plus 2 width is equal to the total perimeter, 126 feet. And the amazing part is we've already solved for length, right? Right there, we've already solved for length. So we're just going to plug that right in there. Whoop. We're going to plug that right in there for L. And then we can figure out the width, because we need the width to find the area. So to find the area of the pool without using your calculator, that's just length times width equals the area. So that's our goal, that's our finish line, is to go ahead and let's find the length and the width with 2 equations. Cool. Okay, so length is what? Length is equal to 2w plus 3. So 2 times, again we're going to plug it in, 2w plus 3 is equal to the length. So that's here in place of the L. So we'll go ahead and put that right there in place of the L. There we go. And then we have our plus next, plus 2w equals 126. So now we'll distribute and solve for w, right? Solve for w. So we'll distribute it through, so we get 4w plus 6 plus 2w equals 126. Okay, well we can add those together, 4w plus 2w, add those together and you get 6w. And then bring down your plus 6 equals 126. We minus 6 to the other side, so we get 120. So now we have 6w is equal to 120. We divide by 6. So 6 goes into 12 once and 0 times. So that's just 12 divided by 6 is on 2, so 20. So 20 is our width. So now we know that our width is 20. Now we just need our length. So now that we've found our width, what can we do with it? What can we do with our width now that we found it? Now that we found our width, what are we going to do with it? Plug it in. Plug it in. So we're going to come over here, and we're going to plug in the w now. So length, solve for length. Length equals 2 times w, which is 20, plus 3. And 2 times 20 is 40, plus 3. So our length is 43. And now we can use that and plug that back in to the area formula. And so now we just have to do 430 times 20 to get the area of the pool. Okay, so we'll do it over here. We'll come back over. No, let's do it here. Okay, so what's our area? Our area is 43 times 20. It says without your calculator. 0 times 3 is 0. 0 times 4 is 0. 2 times 3 is 6. 2 times 4 is 8. So we get, add those together, and we get 860. So 860 feet squared is the area. That was a good one. That was a good problem. There's our finish line. So 860 feet squared is our answer. 860 feet squared. Good job. Okay, the next one I think we should try using our calculator. It's kind of crazy. Matt and Ming are selling fruit for a school fundraiser. Customers can buy small boxes of oranges and large boxes of oranges. So we'll say S for small and L for large. Matt sold 25 small boxes of oranges and 18 large boxes of oranges for a total of $409. Ming sold 16 small boxes of oranges and 11, so plus, we'll say and in this case, so plus 11 large boxes of oranges for a total of $225. Find the cost of each of one small box of oranges and one large box of oranges. So we're basically solving for S and we're solving for L. And it could be X and Y. You could call it X and Y. So if you don't like S, then you can call it X. And if or you will call, now let's leave it S and Y, that's fine. But when you plug in your calculator, it'll be a little trickier. Okay, so solving for S and L. Okay, so we can do substitution, right? Do substitution. So let's see. So it doesn't say without your calculator, so I think this is the calculator section. So I think we should just solve then. Solve for one letter. Let's solve for S, for example. For both equations. So we're going to go ahead and solve for S for both equations like this. Here we go. So I'm going to solve for S. So I'm going to go ahead and I'm going to go to minus 18L to the other side. And then I'm going to solve for S by dividing. Because right now it's being times. So I'm going to divide by 25 over the other side. So there's one equation now, right? S is equal to 409, put in parentheses, minus 18L. So instead of L, I'm going to call it X, I think. Because when you plug in the calculator, you have to call it X. So maybe call it X actually. Then we're going to solve for S over down here too. So we're going to minus L, 11L to the other side. And then divide by 16. Divide by 16. And so that's what S equals. So S equals that as well. So S is equal to 225 minus 11L. So 225 minus 11L. Probably call it X actually for your calculator. All divided by 16. Okay, so now we're just going to put both of those in our calculators. Put them both in our calculators. Don't you little? No? Got it. Okay, so we'll go back to Zoom 6. And we'll go ahead and clear our graph and plug those in and find the intersection just using our calculator. Okay, here we go. So 409 minus, we're going to say instead of L, we're going to say X, divided by 25. And then down below we have 225 minus 11x divided by 16. And then we'll push graph, and we see a couple lines over there. So we might have to change our window now and go to the right. So go to the right, maybe 100, and maybe go up. Go to 100. I just chose 100. We could be wrong. We'll see. an intersection there. Still kind of hard to see there, though, isn't it? Still kind of hard to see there, that intersection. But we do have the equation of two lines. So what do you think? Where should we go to see where our intersection is? Right? Where does it look like it's crossing? Where does it look like it's crossing? I don't know. It's hard to tell, isn't it? So maybe I'll zoom in at the x-axis to see if that helps us or not. So the x-axis is right about here. There we go. Yeah, is it intersecting anywhere? Doesn't look like it, does it? Pretty close though, we're getting closer. Getting closer. The y values are getting closer. Pretty close right there. Let's go and zoom in right there. Zoom in, enter, enter again, enter again. Still not quite there though. We're looking for this intersection. It is getting narrower over here. Still don't know. This is kind of crazy. Let's see. Just trying to find that intersection where they intersect. I think I did everything right. Let's double check. So we had a 25 and 18, and then we had a 16 and 11. We could have done elimination or substitution with these big numbers. We could have. That would have been fine. But it just didn't look that easy with those numbers they gave us, right? Okay, so oh, I made the same mistake that a student made today. Whoa, I made the same mistake. That's supposed to be a 5. 255. Now we'll find the intersection pretty easy. So I'm going to go here and change it to 255. Thanks, Ellie. Name drop, Ellie. I think it was Ellie. Okay, we'll push graph. There's the intersection. So it looks like the intersection is up here. They kind of blend together. You see it? They kind of blend together. As long as you're close, just about there. We'll go second calc, second intersect, and we'll go enter, and then enter, enter, enter. 13.7. So we called L, which was X, 13, and then 7. So that means that our small boxes are $7 per box. Remember, because it goes 13, 7. And then our large boxes, we're going to say, is $13. So X or L is $13. That's X or L, and then Y. Cool. And that's the same as L and S. We got it! Woo! Cool. So thanks for watching. Thanks for watching. Go back and watch some more. Keep on studying. I want you to ace this test. You behind the screen. Thanks for watching. Woo! Gonna miss you over the summer. Gonna miss you. See you soon for the test. You got this. Bye for now.